So my name's Meg Crofoot, and I'm a scientist here at the Max-Planck-Institute and also at the Smithsonian Tropical Research Institute. And I've been living in Panama for the past 5 years, working primarily on capuchin monkeys in the rainforest there. But what I'm going to be talking about today is some work that I did last year in Kenya that's more sort of associated with the institute here. And so as I'm talking, like if you have questions, just ask them right away. Like you don't have to wait till the end or anything. And yeah, anything you're interested in that you want me to talk more about, let me know. So today I'm going to be talking about this research that I'm doing on animal groups and how they make decisions. And can you advance my slide for me?
Yeah.
Okay, so transitions from living alone to living in groups has happened a whole bunch of times over evolutionary history. So you've got insects, you've got both solitary and social bees, ants, fish, all kinds of mammals, and then most notably us a lot of the time. Humans are an incredibly pervasive. We've been very successful, and in large part it's because of our sociality, the fact that we can come together to do more as a group than any one of us could do as an individual. So what are some of the benefits of living in groups? Yeah.
People share ideas and help each other.
Mm-hmm. So you can sort of pool information.
Yes, and protect each other.
Yeah.
You're much stronger than alone.
Yep, so against predators or against other groups,
Yes.
either way. Anything else? You can split up labor, so we don't all have to be able to do everything well. You can specialize in doing one thing and then sort of collaborate with others to get everything you need. You can divide labor in terms of childcare. There are all kinds of benefits you can get from living with a whole bunch of other individuals. But you also have a bunch of costs. So what else? What are some of the troubles that you run into with groups? Yeah.
There might be many disputes.
Mm-hmm. Sort of conflicts of interest or what you want to do, or yeah. Okay.
Or you may be slower than alone, and
Mm-hmm.
Your aims will not be reached, for example.
Okay. Yeah. Yep. Especially if you can't all agree. You're also competing over things like food. So if you arrive at a dinner, whether it's a fruit tree or actually a dinner on table, if you're a bigger group, you're splitting that up more ways. And so the cost of group living that I'm particularly interested in is this idea of when you have conflicts of interest in a group, you have to come to some sort of a consensus or the group splits up. So how do you make those decisions? How does a group, this group of mongoose, maybe it's a good thing to be in a group. There are more of you. If the predator attacks, he'll probably only kill one of you rather than, so your risk is diluted. You can cooperate together to potentially scare away, I don't know if you can actually scare away a cobra, but in theory, maybe you're bigger and more formidable against enemies. But you also have this problem that, this guy's kind of hanging back. He's not really looking all that interested in participating. So you potentially have conflicts of interest within the group about what they want the group to do. Should we run away or should we stay here and defend? So there's been a ton of math done about this in the last 10 years. This has been a major modeling question of how do groups of individuals decide what to do. And you can imagine that from the perspective of understanding this is interesting not only for animals, but for understanding how optimal decisions get made in human systems, looking at crowds of moving people, and even looking at when you assume that people can talk and communicate, how do you arrive at the best possible decision? So people have spent a lot of time working out the math. And what's interesting is that even though you might think that despotic groups, so groups with a dictator or a single leader, might be the most efficient way for groups, especially nonverbal groups, to communicate and to function, actually democratic decision making is actually favored, at least according to the models, over this huge range of conditions, which I think is really interesting. that some sort of voting process often turns out to be the optimal decision, or so the optimal strategy. But as you can imagine, testing these models is kind of difficult. So if you work on fish in a lab or insects in a lab, you can set up decision-making processes for groups and track every individual using cameras and know where they go. But if you're interested in what animals in the wild do, you've got a problem. Because, well, you can watch one of these animals, right, and record what they do. And generally the way primate behavioral work is done is that you're just standing there watching a single individual and writing down what they do. But when what this guy does depends on what the other animals around him are doing, so when his behavior is contingent on what the other animals in his group do, you have a big problem, because you can't record what everybody's doing all at the same time. You can't watch everybody and take notes on them. And in wild habitats, it's too complicated. You also can't really use videotape very effectively. So try to just pick an animal and try to follow them throughout this little video clip. This is the baboon group that I watch. Walking across a chunk of savanna. Baboon groups tend to be big. They can be as big as 150 individuals all living together. They can also be small as like 15. And they're quite social, so there's usually a lot of stuff going on. Individuals interacting, playing, fighting. And then they also disappear from view an awful lot. So were you guys able to follow your individual? Pretty well? Kind of? Maybe? No? If you were, did you notice, for example, the big male pulling the little guy's tail? Anybody? No? So one problem is that when you're watching one individual, you miss what everybody else is doing, right? You can only focus on one thing at a time. So this has been like this big problem in trying to understand how social groups work in natural habitats. We can't watch everybody. Video doesn't work. What are you going to do? Well, who has a Navi? And you guys all, pretty much every car these days has a Navi, right? So do you know how it's a GPS system is using satellite, it's 11, I think it's 11 satellites, or is it 18 satellites? Anyway, satellite systems to pinpoint your position on Earth. And this idea isn't new. The GPS has been around for a while. The difference is that it used to be that GPS collars were too big. So this is the original GPS collar. It used a car battery, and it only lasted, I think, 15 days. So for a long time, the battery power that GPS required meant that you couldn't really use GPS for tracking animals very well. But that's all changed recently, and a big part of what this institute does involves tracking animals using these new, much smaller GPS collars. So these are actually still pretty big. These are the baboon collars that I used. Yeah, put it on and see how heavy it is. But they also get much smaller. So these are tags that we would put on birds, for example. And what they do is let us track in really high precision where animals are going. So this was, I made a mistake and accidentally turned on a GPS collar here in the Zurich airport and tracked, it's that one I think actually, and tracked my return to Möggingen up there. And so what's interesting about these collars is that they're recording one point every second, so you get this very high resolution track of where the collar has been. So this is, just a blow up. You can see, you not only can see what road I'm on, but you can see which side of the road I'm on. And so my idea was that if we could put these kinds of collars on every monkey in an entire group, you could actually look at how they were interacting with each other. You'd have a record of what the whole group was doing and how they were responding to each other. And so people have used this kind of stuff to track this kind of technology to track single individuals a lot. People haven't ever really used it to track a whole group this way. So the idea was you catch a whole group of monkeys, You put collars on them, and then you can look at how they're responding. When one animal changes direction, do other individuals follow and align with him? Or do they sort of, one individual goes off and nobody follows them, they follow somebody else. You can look at these leader-follower dynamics, and in theory get at how decisions are being made in the group. So I chose to work with baboons because, well, for one thing, they're really widespread all across Africa, although several different species all across Africa. I didn't work with these guys, but these are my favorite. Hamadryas. They live up here. And so one nice thing about a really widespread animal is that people don't get too upset when you say you're going to do something like put collars on them. They're not endangered. And they also are a big problem in Africa because they're a very successful species. They survive well in areas that have like high human density. They do a lot of crop raiding. This is a baboon in South Africa in a vineyard. They cause quite a lot of problems. Just a recommendation, if you ever go on safari to Africa, don't feed the baboons, and just generally speaking, food in the car even is a bad idea. But they also live, all over human communities. So understanding how their groups work and how groups make decisions about where to go, like which are the individuals that are leading groups into new places, for example, or into conflict with humans, are questions that we would like to know for sort of scientific as well as very practical reasons. So this is a baboon group. There are a lot of them. Can you guess who these guys are? Males, females, kids. So these are all female baboons, and they form the real core of a baboon social group. So female baboons stay in the same group their entire lives. They're born into a group, they stay with their sisters and mothers and aunts and grandmother their whole life. And what that means is they have these very intricate political and social relationships. So you have matrilines, so families of females, which have different dominance ranks. So you have a high-ranking matriline, a second-ranking matriline, a third-ranking matriline. And how high or low your dominance status is has a huge effect on how many babies you can have, how much food you get access to. It really matters who you're born to. And one of the cool things about baboons, I think, is that, so a mother, you inherit your dominance rank. You inherit a place directly below your mother until she has another baby girl. And then as soon as your mother has another baby girl, that new infant kicks you down a notch. So it's always the youngest infant of a mother who's the next highest ranking in the group. So these guys are the males, much bigger. They're about twice as big as the females. And males, unlike females, when they hit sexual maturity, have to change groups. They have to leave their group and go find a new group, and hopefully be let into that new group. And it's kind of a stressful time for a baboon. Baboons, in general, with the exception of this one period when males are looking to join a new group, they're always together. You very rarely see a baboon off on its own. So this period when a young male has to leave his group and find a new group is really stressful. They're exposed to predators, they're off by themselves, their stress levels shoot up. It's not a good time in a baboon's life. And then they arrive at a new group that they want to join, and they get beat up by everybody over and over and over again. So life as a male baboon has its downsides, but they're huge. And so they also tend to, once you've established in a group, you're also the highest ranking individual. So the males in general outrank all the females, except the females can form coalitions, so they don't get completely dominated. And so one of the nice things about baboons, a lot of animals in general, but spend most of their time finding food and eating food, which makes them not all that much fun to watch. I don't know, I mean, watching a grazing animal is But baboons also do all kinds of social stuff. So they spend tons of time grooming each other. And these grooming relationships may have a cleaning function, so they may be removing ectoparasites, so ticks and fleas and stuff. But it's also about social bonding. So you groom with your friends, you groom with your family, and it reinforces these social bonds and brings down stress levels so you can actually measure that their cortisol, stress hormone, levels drop as they're being groomed and as they're grooming. So it's not just being groomed that is relaxing, but actually the act of grooming somebody else. And there's a real cost to being that loner out on the outside of the group who never gets groomed. The sort of peripheral individuals have much worse health outcomes. They also play a lot, which makes them fun to watch. So this data that I'm about to show you comes from Impala Research Center in Kenya, which is a Smithsonian affiliated research site, and is really nice because as opposed to like sleeping in tents, I've got this nice house to stay in. And it's one of the weird things about doing field research. I've worked in the middle of nowhere in Borneo. I've worked in Panama in the rainforest. I've worked a lot of places that have no amenities. It's really nice when you want to do science to actually have electricity and internet and food, shower. Anyway, there are all kinds of things that are really nice, and Impala has a lot of them, which, you know, it sounds silly, but an awful lot of effort can go just towards keeping yourself fed and clean and your clothes clean when you have nothing but a stream as your water supply and no electricity. So Impala's great. I'm a big fan. And this is what it looks like. So it's up on, do you guys know where Kenya is in Africa? I pointed out, yeah. Anyway. It's up on a plateau near Mount Kenya. So it's quite high, it's quite cool. And it's relatively open. You don't have big trees except along the river, and even those are relatively few and far between. Now, because of all the predators, baboons have to sleep up high. So they either want to sleep on cliffs or in trees. And what that means is that sleeping sites really sort of tie down where they live and where they go. If there's not a good place to sleep nearby, there are no baboons there. And so coming from primarily tropical forest work, this was really fun because there are awesome animals in Kenya. There's nothing quite like trying to get to your research site to download data and realizing that there's an entire herd of elephants between you and there and between you and the place you want to go, and you're just not going to be able to do it today. So to do this, one of the first things that we had to do was habituate the primates. So this is sort of a weird methodological thing that works for primates and not for so many other species. So you can habituate some other kinds of animals. But primates, if you hang around long enough, get bored with you and stop paying attention and just sort of let you be there without being scared or really even paying attention to you at all. And it makes them nice for observational work. A lot of other animals either take much longer or are very difficult to get to the point where they're just ignoring you. So we spent a lot of time following them around, sitting, waiting for them to stop freaking out. They're also highly food motivated. It turns out baboons will do just about anything for corn, or any other kind of food for that matter. I sort of have this idea that like every person and every species has the thing that they would go in a trap for. It turns out it wasn't hard to find baboons. So to catch the baboons, we made some traps and put corn in it. It turned out to be much easier. I figured it would take us weeks and weeks and weeks to get the baboons inside the traps. No, first day. You put corn in there, they'll go in. And in fact, they got so used to the traps that they had the babies using them as jungle gyms. So basically, set it up like this, strings to pull the doors closed, and then you catch a whole bunch of animals. Which we had to anesthetize because baboons have big, big teeth. So to keep them safe and to keep us safe, we put them to sleep. And measured them and did basic health care checkups to see what their health status was. We put on collars, we weighed them, we took samples to collect samples to let us do the genetics, like blood samples, as well as looking at their ectoparasites. So did they have ticks, did they have fleas and stuff? And it was always a bit harder with the big males. Yeah. So this is the alpha male of the group, just so. It's a big dude. And so in the end, what you have is a whole group of monkeys. Oh,
Sorry.
no, that's okay.
One back.
There you go. One forward.
You.
Me?
Is it a video?
Yeah. So a whole bunch of collared baboons, a whole group wandering around. So this group was about 45 monkeys, and we caught everyone who was big enough to put a collar on, which was 27 of them. So some of the small ones are they're just too small to put something this big on. And what this really let us do was sort of start to tease apart all of these both fine scale and larger scale interactions that were going on. So this is what the data looks like, if you can get the thing playing. So each dot is an individual baboon. And what we just saw sort of translates into this. Well, and a little more. So this is about an hour of data. It's sped up a little bit. But you're seeing the group, they were foraging and feeding, and then they started to move back, and it's getting late in the day. So they start to use the road a little bit and head home. And then you have this interesting thing where a couple individuals were still hungry and went off to feed in a fig tree, I think, up at the top corner, and then came back to the trees where they sleep. So what we're doing with this data, we have, each individual baboon, we have this trajectory of their movement, right? And the original plan had been that if you look at when an individual changes its direction, how long does it take every other individual to line up with it? And the individual who everybody else is lining up with is probably the leader. That was our idea. And if you have a single leader, well, that's probably some sort of despotic or dictatorial decision-making process. If you have several leaders, you might have sort of a more hierarchical system. Like, for example, we might expect that the leader, the top-ranking female in each matriline, for example, those individuals might decide amongst themselves where they were going, and then everybody else just follows them. Or you might have some sort of more democratic process where anyone can lead depending on how many other individuals want to go the same way they want to go. And you just need a majority of the group who wants to follow you. So that was the idea. Unfortunately, it didn't really work so well. And the problem is that the method was, oops, sorry, can you play this video? Yeah. The method was designed for use with pigeons. And so if you watch this flock, you see how pigeons do this nice coordinated movement? It's really quite different from what the baboons were doing, right? So we're still working. Basically, it's a question of scale, but we're still working to get the algorithms to actually give us the answers we're hoping for. So we need to. It's not quite working with the baboons yet because you have these periods where they're highly synchronized, just like the pigeons, but then you have areas where one goes off and they're not having the synchronized movement, and it keeps messing up our algorithm. So we're having some problems. But instead we've been, this video isn't going to work, I don't think. Try it, but I don't think it's going to work. Oh, no. So basically what we're doing instead, right now, so we have a huge data set. It's 20, we tracked these 27 animals for 30 days at 1 GPS point per second. So we have over 26 million data points, which is a lot of data. And so what we're doing right now is mining it for periods where you have two individuals who are following each other really closely. So looking at just these segments of time where individuals are highly coordinated. And then we're looking at leading and following across the group. So this is a mess, and I'm sorry I couldn't make it cleaner. But each red dot is a single monkey in the group. And the arrows point from a follower to a leader. So from a follower to a leader. And this is based on looking across the entire data set at these highly coordinated periods of time. And so, again, if it were despotic decision making, you'd expect everybody to be following a single individual and that individual to be following nobody, which is clearly not what that picture just showed. It showed a mess. And right now what we're trying to do is figure out so it's clearly not this despotic decision making process. So if you'll notice, there's some individuals that are highly followed, that have a lot of arrows pointing in. And what's interesting is that these two are adult females, relatively high-ranking adult females, and that's her juvenile. So basically we think everybody's following the juvenile because the juvenile's just with his mom. Another interesting bit is this is our alpha male, who's followed, but not nearly as much as these high-ranking females. So the alpha male is leading sometimes, but he's not the leader in the vast majority of the cases. And then you've got a couple individuals who are never followed. And these are all subadults. They're not old enough to be with their moms still, but nobody is really paying attention to where they're going and what they're doing, and nobody seems to be tracking their movements.
I'm sorry, Meg, is it a female or male? The subadults?
One of each. So female, male, male. Yeah.
What's up with the baboon number 12 and
12 and 13 and 22. Ah, the joys of science. Those are the ones whose collars stopped working on day one. We had a software bug that that knocked out a few collars early on. And unfortunately, this guy is one of our big males. He's not the alpha, but he's one of the big ones. So it was really sad. So yeah. So right now, I have a sense that we have sort of both of these processes going on, potentially for different kinds of decisions. So for example, you might expect sort of once individuals have sort of fed for the day and sort of, yeah, you might expect different kinds of decision-making processes for different kinds of decisions. So the decision about whether you're going to eat versus when it's time to go to bed might be made in different ways. And so what we're trying to figure out, what I'm trying to sort of dig out now from that very messy data I showed you, was looking at particular segments. So from when a group is stopped and starts to move and stops again. So looking at these segments and trying to pick out, okay, in this given segment, was this a hierarchical decision or a democratic decision? And that's what we're trying to do right now. And unfortunately, I don't have the answer for you. But come back in a year and maybe, or 6 months. And hopefully I will. And so this is the group of people that helped me with this project. It was a huge, catching that many animals in 2 weeks was a huge amount of work. Particularly Matthew Mutinda, who was the KWS, the Kenya Wildlife Service vet, who helped us, and then Suzanne, who was the vet from the Smithsonian. Animal capture is hard and potentially dangerous, and when you've got these big adult males with huge teeth, even more so, and they were really important. So I don't know if you guys have questions or, yeah, anything else, but yeah.
Why did you choose the baboons?
Oh, it's a good question. So I chose baboons because I was interested in a species that had a complex social organization where you had both dominance going on as well as these sort of family relationships. So that where you have these sort of two axes of social interaction. So you have dominance that's organizing social behavior, but you also have relatedness and kinship. And so baboons are good for that. They live in pretty open habitats, which the GPS, it's working better and better under forest canopy, but it degrades your signal. So it's easier if you're working in an open habitat. And they habituate relatively quickly and we're trappable. So when I work in Panama, I have to dart the monkeys. And so it's the species I work with in Panama is capuchin monkeys. They're much smaller and they live in the trees. So you have to dart them in the butt with a dart full of anesthetic, and then you have to run around with hammocks trying to catch them as they fall. And so the possibility, it was sort of twofold, like dangerous to the monkeys to try to catch so many, and then probably actually just not feasible to actually catch a whole group. I needed something that I could trap, that we could do, have 35 traps out there and catch them all in a couple of days. So it was a combination of like good scientific reasons and just logistical. Like it was a pretty easy system to work with. It's also helpful that baboons are particularly food motivated. So it's always nice when you can manipulate, get them to enter traps without too much trouble.
Do the apes tolerate the collars?
They do. So I was really...
Except of the three we saw
Right, so that wasn't anything to do with what they did to the collars. That was just the software had just a glitch. So they actually did. I don't have any of them here with me. We got them back after. So I had an automated breakaway system. So basically an automated release mechanism. So the collars would just fall off when the study was over. So we have the used collars, and they weren't pulling at them. They weren't biting. The collars are completely intact.
And they don't disturb them when they grooming.
They groom around them. They groom under, but they
they don't try to get it away.
No. So when they first wake up from the anesthesia, they'll sort of sit there and pull at them for a few minutes. But within 2 hours, usually. I think we had one individual who maybe sat there for 3 hours, but within 2 hours they've stopped messing with them. And because, so you can feel the antenna in here. We were able to build the antenna into the collar itself. So sometimes monkeys will play with the antenna on a collar because it sticks out. And so there's nothing really that sticks out from the collar.
And is there a project, something like this ever happened before, or is it the first time that...
This is the first time anyone's ever tracked an entire group of animals in the wild this way. So it's a new kind of data, and I think that one of the really cool things is that I think the kinds of methods that we're developing for figuring out leadership and followership and how choices are being made are going to end up being applicable to a lot of systems, including human crowds, so understanding how humans move through crowded spaces and looking at traffic flow in human environments. And then also, people are doing a lot of the same sort of thing, trying to get robots to move together. So trying to get sort of building artificial intelligence systems. So understanding how animals do this sort of thing may be interesting for getting robots that can coordinate their movement.